Hello everyone, welcome to Dimes and Nickels by Martin Tutorials. As a reminder, I have two YouTube channels, and as today's question is relatively easy, it's fun algebra, I plan to send it to both my YouTubes. I actually did this YouTube about 2 months ago and I'm redoing the exact same question. The reason is, in that YouTube, I made a big fuss about my YouTubes and what they offer, etc. But my YouTube has since changed its name. At that time, the name was not Variety and Fun Math. It was something else. So it would cause a lot of confusion if I'm making a big fuss about this YouTube offers this and that YouTube offers that. Meanwhile, the name has since changed. So now I'm redoing it with the correct name. On to today's question. Peter has nickels and dimes in his pocket, okay? And depending where you live, you may or may not call it nickels and dimes. It could be 5-cent coins or 10-cent coins if you don't know the names nickels and dimes. Altogether, he has 20 coins that total $1.55. The question is simply, how many nickels and how many dimes does Peter have in his pocket? Just a reminder of the equations, I always think of equations like a balancing scale. If the two sides balance, it will remain balancing if I do the same procedure on each side. So if these both weigh the same, if I add 2 grams to the left and 2 grams to the right, it will balance. If I add 2 grams to the left and 3 grams to the right, it will not balance. If I triple the left and triple the right, it will balance. If I triple the left and times the right by 4, it will not balance. So always keep that in mind while doing algebra questions. So to begin with, I let D be the number of dimes and N be the number of nickels. And to prevent confusion, D is the number of coins. So if these little tens represent a dime, D represents not the value, but how many. That's 1 dime, 2 dimes, 3 dimes, 4 dimes. Let's pretend there were lots more. I count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, ... That's what D represents. Same thing with N is how many nickels. Let's say I've got all the nickels sitting on this card. I just drew 3. Doesn't mean the answer here is 3. I add up those nickels, 1 nickel, 2 nickels, 3 nickels, 4 nickels, 5 nickels. I add up how many coins. That's what N represents. And I'm using letters because I don't know the true correct answer yet. That's what I'm solving for. Okay, now what I now do is I take these two sentences and convert them into equations. Okay, like it says, he has 20 coins. D plus N equals 20. The number of dimes plus the number of nickels equals 20. So this equation's got nothing to do with the value of the coins. It refers to how many coins. If we count up all the dimes and count up all the nickels, it'll add up to 20. Then they total $1.55. Now we're no longer talking about how many coins, but the value. Now remember, dimes are worth 10 cents each. I'm just making up numbers now. I'm not saying this is the answer. If we had 7 dimes, it would total 7 times 10. If we had 4 dimes, the total would be 4 times 10. If we have D dimes, the total is D times 10 or 10 times D. Same as before, except we don't know what the number is. I put D. Same thing with nickels. If I had 15 nickels, the total would equal 15 times 5. If I have N nickels, the total would be N times 5. And I'm putting N because I don't know what that number is. So there is my 2 equations. That's number of coins equals 20. The value of the coins equals 155. The question said $1.55. I'm using cents. That's 155 cents because it's easier to do if I do away with decimals. So the value of all the coins is 155 cents. So what I do now is I'm going to take this equation and I'm going to multiply through by 5 and the top equation. And the reason is, I always say with algebra, firstly, it has to be true, and secondly, it has to be helpful. It is true. Think of my balancing scale. We have an equal sign. If the left is multiplied by 5, the right is multiplied by 5, it is still equaled. That's logical. If this left equation equals that right, this times 5 must equal that times 5. That's why it's true. Now, why is it helpful? When I subtract equations, I'm going to eliminate a variable, and that makes it one step closer to solving. Because again, we've got a balancing scale. If left equals right and left equals right, left minus left equals right minus right. Does that make sense? It's like if this equals 150 minus 100, that will equal 150. That's 155 minus 100. The left will also be 155 minus 100, because this equation equals 155. That equation equals 100. So left minus left, 10d minus 5d equals 5d. 5n minus 5n equals 0. The n's disappear. It's 5d. 155 minus 100 is 55. So 5d equals 55. And once again, my balancing scale, if left equals right, if I do the same to each side, I divide each side by 5, they will still be equal. It's true because I'm dividing by the same amount, and it's helpful because it solves for d. d equals 11. And once we know d is 11, I can substitute d in. We know d is 11. So instead of saying 11 plus n is 20, instead of saying d plus n is 20, I say 11 plus n is 20. Then here's my equal sign. If the left is reduced by 11, the right is reduced by 11, it will still be equal. So I can say n equals 20 minus 11, which equals 9. So we have just solved that d is 11, the number of dimes is 11, and number of nickels is 9. And now I'm checking. We told you 20 coins. 9 plus 11 is 20. Correct. We told the total value is $1.55. Let's check. 9 nickels plus 11 dimes, 45 cents, plus $1.10 equals $1.55. Correct. So that's our answer to the question. 9 nickels and 11 dimes. And thank you for watching.